All right, let's talk about this. We've all been there, right? You've got this brilliant idea, this perfect concept for an application. But how do you actually take that vision and turn it into a solid, working database? Well, that journey from blueprint to database is exactly what we're going to map out today.
Because, let's be honest, without a really clear plan, this is what happens. What the customer wanted, what the project lead heard, and what the developer actually built, they can end up as completely different things. It's that classic tree swing cartoon. A simple idea gets totally lost in translation. It's a perfect and kind of funny example of how miscommunication can just completely wreck a project's original goal.
So here's the million-dollar question. How do we avoid that mess? How do we make absolutely sure that what we design is what gets built and that our data has a strong logical foundation right from the very beginning?
The answer is you start with a proper blueprint. And for us, in the world of databases, that blueprint is the Entity Relationship Diagram, the ERD. Think of it as the architectural plan that gets everyone on the same page and guarantees that the structure we're building is solid, scalable, and actually makes sense.
Okay, so the very first step in this whole process is all about laying the foundation. We're going to take the core ideas from our design, the entities, and turn them into the main building blocks of our database, which are, of course, tables.
And the first rule couldn't be more straightforward. Every single entity that you've drawn out in your ERD is going to become its own table in the database. It's that simple. Just think of your entities as the main nouns of your system. The people, places, and things you need to keep track of.
Now, most of these entities are going to be what we call regular or strong entities. These are the concepts that can stand on their own 2 feet. A great example is an employee. They have some piece of information like an employee ID that makes each one of them unique.
And here's what that looks like in the real world. Our employee entity becomes the employee table. Each one of its attributes, like name, position, pay rate, turns into a column. And that unique identifier we just mentioned, the ID, that becomes the table's primary key, which makes sure that we never mix up 2 different employees.
But, not every entity is so independent. We also have to deal with weak entities. These are the ones that can't be uniquely identified all by themselves. They kind of depend on a parent entity just to exist. Think about it like an assembly line. An assembly line number only makes sense if you know which factory it's in.
So, weak entities, they get their own tables too, but there's a little trick to it. To make them unique, they have to borrow the primary key from their parent entity. Then, they combine that borrowed key with their own partial key, and together, those 2 pieces create what we call a composite primary key.
Let's see how this plays out in our example. The assembly line table borrows factory city from its parent, the factory table. It then combines that with its own key, which is just the line number. So the primary key for this table is both factory city and number put together. That's the only way we can be sure that line 5 in Chicago is different from line 5 in Tokyo.
Okay, so we've got our tables, but right now, they're just these disconnected islands of data. The next big step is to build the bridges between them. We need to translate all those lines, the relationships from our ERD, into the actual database structure.
And when it comes to doing that, we've basically got 2 main strategies. The first is to borrow a key. This is where one table gets a new column that points to the primary key of another table. We call that a foreign key. The other option is to create a bridge, where we make a whole new table, often called a cross-reference table, just to link 2 other tables together.
So how do you know which one to pick? Well, it all comes down to the relationship's cardinality, which is really just a fancy word for how many things on one side can connect to things on the other. And here's the rule of thumb. If it's a one-to-one or a one-to-many relationship, you just borrow a key. But if it's a many-to-many relationship, you don't have a choice. You have to build that bridge.
Let's go back to our employee table for a second. To handle the work-sat relationship where, many employees can work at one factory, we just add a factory_city foreign key column. Simple. And for the supervisors relationship where one employee can supervise many others, we add a supervisor ID foreign key. It's a really clean and elegant way to build those connections right in.
Now for that special case, a many-to-many relationship. Think about vendors and parts. A single vendor can supply lots of different parts, and one single part could be supplied by lots of different vendors. We can't just add a column to fix this. Instead, we have to create that bridge, a new cross-reference table called vendor part. Its only job in life is to connect a vendor to a part, and maybe, like in this case, store the price for that specific combination. And why are we so careful about following all these rules? Well, this quote really says it all.
SQL, the language we use to talk to our database, was built from the ground up to work with these kinds of clean, organized, normalized structures. By following the rules, we're basically setting ourselves up for success later on. We're designing for the tool we're going to use.
All right, we've definitely covered the big pieces of the puzzle, but ERDs can have some other, more nuanced types of attributes. So let's quickly go over the finishing touches and how to handle these special cases.
So, here are the three main types and the rules. First, for composite attributes like an address, you don't make one address column. Nope, you break it down into its pieces: street, city, zip code. Next, for derived attributes like someone's age, you don't store it at all. You just calculate it from their birth date whenever you need it. And finally, for multi-valued attributes like skills, you have to create a whole new table.
And here is a perfect example of that. A single computer model might have a bunch of different applications, right? It could be for gaming and for business. To handle this, we create a brand new table, Model Application. Each row in this table just links a specific computer model to one of its possible applications. This is super flexible because now we can store as many applications as we want for any given model.
So, we've walked through all the technical steps, but it's so important to connect this all back to the big picture. This isn't just some boring academic exercise. This is about building a database that's reliable, efficient, and isn't going to turn into a massive headache for you down the line.
I love this quote from George Harrison because it perfectly captures the danger of just skipping the design phase. If you don't have that clear blueprint, that ERD, you just end up with a chaotic mess that's impossible to manage and query. Any road will take you there, sure, but there is probably a pretty awful place to be.
And this is exactly what that chaotic there looks like. This is such a common mistake. People just start adding columns for repeating data. It feels easy when you start, but trust me, it's a total trap. This design is rigid, it's wasteful, and it's an absolute nightmare to work with.
I mean, just think about it. How would you add up the total payments for one customer here? You'd have to literally sum up 12 different columns. And what happens when a customer makes a 13th payment? Are you going to add a payment 13 column to the entire table? The whole design just falls apart with the simplest real-world curveball.
Look, following this conversion process, it will give you a solid foundation, I promise. But the final question, the one you should always be asking yourself, is this: will it stand the test of time? Because a truly good design doesn't just work for you today. It's flexible enough to evolve and adapt to whatever you're going to need tomorrow.